Yeah, hi Shubham.
Uh,
Yeah, can you briefly explain about yourself?
Hi Ashok sir. I am Shubham. I have around 1 year of experience in DevOps and cloud field. After that, okay, so my DevOps and cloud experience comes from my internship that I have done during my college. It was not from my college, I had found it myself. It was a US based company. So, around 9 months, I have done the internship in the company. And then, after some time, I started teaching in my college to bachelor students. My field of teaching was Linux and networking most of the time, and then taking practicals and other teacher related duties. After that, I kind of was not able to get the time to focus on DevOps, so I resigned there and get back to my DevOps studies. And here we are now. So, my go to cloud is AWS, and my favorite tool among all the DevOps field would be Kubernetes. I really
Okay,
like it.
good. Yeah. So what are all the services you used in cloud?
In AWS, I have used EC2, ALB, uh, auto scaling, load balancers, VPC, and then databases, Lambda functions also, but not that much that I can confidently say. After that, we have CloudWatch, SNS, SQS, and of course EKS for the Kubernetes and ECR for container registry.
Okay,
And yeah, I guess overall these are the big ones that I've used.
okay. Like what exactly your roles and responsibilities in during the internship?
So in the internship, it was like a very first time thing. So I was not very prepared on real world scenarios, but mostly I would have given like, okay, this is the technology you have to understand and learn, and then I would learn like let's say Docker, and then after a month or something, they would give me some simple task. I would say to just evaluate myself, and after a few months of doing this, learning all the DevOps related technologies, and then Linux related shell scripting or setting up automated scripts to set up Jira, Nextcloud, and other open source softwares that we typically use in the company. After that, I was actually told to work on quantum computing.
Okay,
So yeah, for a few months, I had done some documentation and basic experimentation on quantum computing through IBM.
okay,
Yeah, so overall, it was learning DevOps tool, exploring them, and working on simple automated shell script to set up open source applications.
okay. Um, okay. So in Kubernetes, how the part-to-part communication happens?
So the very first thing is CNI. So these container network interfaces, which are like a middleman to our Kubernetes and actual container networking plugins like uh, Calico, and there's this Falcon. Okay, I forgot the name. It start
Calico,
with S. Yeah, Calico, and there is this F from Philium or something.
funnel.
Yeah, funnel, sorry.
Yeah,
So we need these basic components set up. After that, when we create a pod, our CRI, the Docker, not Docker, container D, they basically pull the image and turn up the container. After that, CRI talk to CNI, basically attach it to the container. So it gives a Linux networking namespace to pod, and then the network plugins create VEth and ETH0 uh, Ethernet interfaces and VEth tunneling to the bridge network that CNI provides. And all the ports are connected to that bridge network. So ports can directly communicate to each other with their IP addresses.
okay. Can you explain the Kubernetes architecture, master slave architecture?
Yeah, so in Kubernetes, we have mainly two type of nodes, a control plane and a worker node. So control plane has all the working, all the controllers and things that manages the Kubernetes, and worker nodes basically run the Kubernetes workload that we want to run. So
Okay,
in worker node, we have kubelet, which first task is to register that node to Kube API server. So it can be considered as a worker node. After then, it uh, task is to see if all the pods that have been assigned are running or not, if the node is healthy or not, and report it to main Kube API server. And in the control plane, we have scheduler, which finds out the most optimal node that can be assigned to a pod so it can run. It does not itself schedule the pod, but simply give it a tag kind of thing like, okay, this pod has to run on this node. Later, it is scheduled by other tools, basically controllers. Then we have etcd, which is a key value database used by Kubernetes to store all the configurations and calls that are important to function the cluster properly. We have kubelet, we have kube proxy, which see the service and networking between pods. So like we have DNS resolution that is done by core DNS. But for core DNS to know like what services it has to forward, kube proxy does the work. Whenever we create a service, kube proxy register that service to core DNS, and then they both work together to provide internal DNS. Then we have scheduler, uh, Kubernetes controller. We have cloud native cloud controllers also. They are specific to cloud technologies. Uh, and we have, okay, I guess that's all I can
yeah, it's
remember at the
HCD
moment.
as well, right?
Yeah, etcd for the database.
So, what is the use of HCD?
Uh, etcd basically uh, has all the configuration related to our cluster. So whenever we, let's say, define a pod and it has, let's say, five replica sets, like a deployment, we define a deployment which has five replica sets. So all this data is written by only Kube API server, like only the Kube API can access etcd database. So it writes that data to etcd database. So it is basically database which collects has all the information regarding our cluster and other Kubernetes components.
Okay, yeah. So it is like not only parts, like whatever action happens
Yes,
in
yes,
Kubernetes cluster, those will be saved in etcd.
yes, yes. This is like the whole brain of our cluster.
Yeah. So we have services in Kubernetes, right? So do
Uh,
you know what is headless service?
yeah. So in this, we basically do not have any IP. We can achieve this by setting the cluster IP flag to none, and so no IP is given to any pod. And the thing is, now we need to actually communicate or use the pod. So for that, we this headless, what it does is directly take the pod IP and put it in the core DNS servers to for the IP routing. So it is basically a pod which has no IP and use directly DNS to do the networking.
Okay, that's right. Um, okay. Um, so do you know about deployments? Different types
Uh,
of deployments in Kubernetes.
yes. So first we have the deployment, which is a top level abstraction of pods and replica sets.
Sorry, what?
So in it is like a top level
No,
abstraction of
what is
pod.
that? Like what you told?
What?
What? Like which one you're telling?
Like the deployment I'm telling.
Yeah, which deployment? No, not
So
deployment YAML. I'm like in case if you have to deploy any code, you know the strategies like blue green.
Oh, okay, okay.
Canary.
So, yeah, we have blue green. I know about blue green and canary. I'm not sure.
Okay.
So basically, in these deployment strategies, instead of completely shutting down our production or entirely replacing our production, we slowly replaces the pods or deployments that we are running. So we basically, let's say, our new version, we let's say we set the in configuration, we define how much percentage we want. So now our production would be running like 10% of the latest uh,
No, that is Canary actually. So blue green is
okay,
like you will have one environment as blue and another as green. So one will be active, another one will be passive. Okay. So you will be deploying it simultaneously. The one which you are telling it is Canary deployment actually.
oh,
So to
okay,
achieve that one, we have to use Istio or any other load balancers. Okay.
okay, okay, sure.
Um, so what is private and public subnet in AWS?
AWS. Yeah, so basically they both are same. What makes them apart from each other is whether they can uh, communicate to the network. So in public subnets, we have internet gateway attached to the subnet, and our resources in that subnet can easily connect to internet. Whereas in private, it can only work inside the AWS network. And if we, for any reason, want to give our internet, sorry, our services in private network internet access, we would have to use NAT gateway or other options like VPC peering and all endpoints.
How many internet gateways can we have per VPC?
I guess only no. I mean, I guess we can have only one.
Yeah,
I'm not sure, but only
yeah,
one, I
we
guess.
can have only one internet gateway per VPC. So in case
Okay.
if you want to communicate between like different VPCs, like how we will connect those things?
So we can, for a simple, like 2 or 3 VPCs only, we can use VPC peering, uh, which
O-
would,
Okay, how we will enable the VPC peering?
it can first connect to the network and options. Is it in the same account? Both the VPCs are either in same account or same region or different region. So the setup varies a little bit. If it is on same account, we simply send a connection or peering request to the other VPC, and you just have to accept that peering connection. Whereas in other, if it is cross region, also it is the same. If it is another account VPC, then we would have to send peering request to that other account, and then that other account user has to accept the peering connection, and then they both can talk to each other.
Okay, so in AWS we have something called assuming a role, right? Assuming a role. What does that mean?
This is used by IAM. So
Okay.
in this, we define we have a role, and in that role, we have all the policies. Now, assuming role actually defines who can actually assume the role. So even if like the role is there, but it's not like anyone can assume that or use that role. In assuming assume role, we define like what can only assume this role. Like in EKS, I have used this where we define like only pods dot EKS dot STS. Uh, like this kind of endpoint only can assume this role. So in short, it defines like who can actually use this role.
Okay.
Like let's say,
Yeah.
uh,
So in
okay,
S3,
mm,
like what is the maximum size of a file that can be saved? A single file?
uh, it's unlimited.
No, single file.
Single file. I'm not sure.
Okay. It will be 5 TB actually.
Okay.
Okay. Mm, so what is NACL? in
So
AWS?
uh, so NACL is a network level access list. So in this, this is like the second option we have regarding securities in AWS. First would be our security group, and this is NACL NACL works totally on the network level, and in this we can define like what kind of traffic we want to allow, or if we want to block any set of IPs, we can do that, which is not possible in the normal security group.
Okay, what is the difference between security group and NACL?
So one is stateful and another is stateless. So in security group, we can only define like, okay, allow this and this. Whereas in NACL, we can define what kind of IPs, what any IP range or any geographic restriction we want to put, or any specific traffic that we want to allow or deny at that level.
No, it's not like that. So security group it is like VM level, and NACL it will be in the VPC level. And in this, like we will have both allow and deny rule. In other, we will have only in case if we allow, the by default the one deny will be allowed. Okay. Um,
Okay, okay.
in EC2, in case if we have something like um, 3 bar 3, what exactly that mean?
What we have?
When you create a EC2 instance, you will have
Yes.
the status right running or something. Then you will see 1 bar 2 or 2 bar 2, right?
These are security or not security checks, basically status checks in either EC2 to define whether the EC2 is ready or the health of EC2. So AWS has some components running in the EC2 which actively pings the AWS. So when like I guess the timeout is 5 minutes or something. So if a EC2 fails to send a ping to AWS for that time, that security or validation check actually uh, gets void, and it marks that EC2 instance as unhealthy. Uh, I am actually forgetting this.
Okay, it's fine. Like you used Terraform.
Yes, I have.
Okay. So like how do you manage different environments in Terraform?
So there are different kind of strategies. One is using Terraform Cloud, which gives you different workspaces.
Okay.
Other would be Git branching strategies where our environments are separated in different branches. Third that I have used is the folder structure, where we define all of our components in as a modules, and then we create other folders for our environments, and then we simply source whatever we want from those modules in that environment. So basically
So
I
how do you manage state file?
state file for that we will use of course backends. I have used S3 for that backend, and it basically does not create any state file on the local but create that on S3, and it is very useful for a production level or in any company, since there are multiple people that could be using Terraform and applying something. So uh, to provide better security and we do not corrupt our state file due to multiple people actively accessing it, we use backends to prevent that.
Okay, if you use S3, you will just store the state file. How do you enable the locking for the state file?
Yeah, so we have Dynamo locking, but in the recent Terraform update, now even S3 also supports this locking by itself, so we do not have to give the Dynamo lock option anymore.
Okay. So like due to some corruption, this
Yeah.
locked, like state file is locked. In case if you have to unlock it, what you will do?
So we can forcefully unlock it, the state file. The command was Terraform. Uh, so I don't remember the command as of
Okay.
now, but we can
Okay.
actually forcefully unlock the state
Okay.
files.
So let's assume like you're not saving it in S3 bucket, and
Yes,
for some reason Terraform state file got deleted. Okay.
yes.
And what will happen to the environment, and what steps you will take to restore it?
Okay, so since Terraform state file actually stores the current condition of our infrastructure, if the file is lost, then if we run Terraform plan or init or apply any of it, our infrastructure will actually recreated. So we already have one infrastructure created. A second copy of that infra will be created again since Terraform has no idea about the previously created infra anymore. Now recover recover from this, uh, we can use the Terraform dot state dot the backup file of a state file which is created by Terraform before changing the state file. But let's say if that won't meet our requirements, we would have to manually import all the resources that we have created in Terraform again by defining the resource ID. Like it will be a dummy template which will have the resources and their ID. And when we run the Terraform init plan apply again, it will recreate that state file.
Yeah, so what you told about import, that is correct, but when you apply, it not like what exactly will happen is different. So when you try to apply that again, it will not try
Hmm.
to recreate, because you will get duplication error, because you will define the CIDR blocks in the network block, right? So what
Yes,
exactly will happen? It will create resources in that CIDR range. Okay. When you try
yes.
to create it again, it will try to create the new resources in the same CIDR range, right? So there will be
Yeah.
duplication. So it will not create the resources. Okay. The only option is to import and reapply it again, and you can manage it in by that way.
Okay, so it's like after importing, we just have to run the till
Yeah.
Terraform plan.
Yeah.
Okay.
Yeah.
Okay.
So it will be managed then.
Okay,
Okay.
sir.
Um, like how do you see open ports in Linux?
Uh, Open ports. I forgot the command actually.
Okay, like how will you see list of open files?
Like list of open files.
Yeah,
Uh, I don't know. Like, can you actually tell me about it?
it is LSOF,
LS dash
OF,
YF.
OF, OF.
OF. Okay.
Yeah.
LS.
Okay, and for example, you have a service. Okay,
Hmm.
when you restart it, like sometimes it will not be running by default. Okay, you need to
Yes.
make that service to be running always. So what you have to do?
We can run the systemctl enable
Yeah.
and the service name.
Okay. And how will you check the network statistics of a system?
The IP and uh, IP or interfaces that our
Like
system has.
ports, those configurations, everything.
Uh, like
It, it,
ports.
it'll be netstat-tulnp.
Yes, netstat. Yes, I
Okay,
actually
how
was.
how do you see the memory of a system?
We can use top or the
Oh,
free command also.
yeah,
A
top.
top and then the
Top
yeah.
is for CPU. Yeah, you can use free.
Okay.
Okay, and in Git, for example, you have multiple commits. Okay, but
Yes.
you have to delete all and you have to keep only one commit. Okay, what exactly you will do?
We have to like revert to a commit or just merge all those commit
No,
in one
for
commit.
example, like you're doing error and trial, and
Yes.
you've done many commits. Okay, you're not yet
Yes.
merged. You're not yet merged. Okay, you're not yet merged.
Hmm.
In the commit history, you have multiple commits. Okay, You have to
Yes.
remove all the commit history and then you have to just keep only one commit ID. So what you will do?
So we can you basically squash all those commit and create basically new commit that will have all of that in one. But
Yeah,
of course, we have to be aware of any conflict. If that occurs, we have to solve the conflict first and then proceed to squashing.
good. Then what is the difference between git pull and git merge?
Git fetch.
Yeah, git fetch and git pull.
Okay, so Git pull basically fetches the latest update, that the latest commit that would have done in the origin repository or like the remote repository. Git fetch, git fetch. I forgot.
Okay, it will just fetch the details from remote, but it will
Yeah.
not
Oh
merge
yes.
in our local repo.
Yeah. Pull will actually merge. Try to merge those.
It will
Like automatically merge.
pull is a combination of fetch and merge.
Yes. Yes. Yes.
So in case you have a Docker image and
Hmm.
then you have to try to reduce the size of the image. Okay, so what are all the
Yes.
steps you will take?
So the very first and common step would be multi-stage Docker file,
Okay,
where uh, if we have let's say a Go application we have, so we
okay,
can basically build our Go application in a full-fledged image, let's say a Ubuntu image or any other heavy big size images, which has all the dependency or libraries available. After that, we can copy our artifact from the first image to another new image by using copy dash dash from and
okay,
the path and the first one. After that, other options are using like do not use so many steps due to layering. It will increase the size of our Docker image. Run most of the mo- Try to run most of the steps in one single line, or like in Linux commands we can use the end percent, double end percent.
mm,
Then using minimal images like distroless or alpine image instead of any heavy image. And then having a Docker ignore file to not copy any unnecessary files. And in case of Node.js, we can first copy our dependency file and install our dependency. And then in second step, we can copy our application file so that when we uh, rebuild it, it will also slow down the decrease the build time because we won't have to again reinstall the dependencies. So like yeah, these are the basic steps we can take.
yeah, good. Um, okay, so how do we manage secrets and config maps in Kubernetes?
So config maps are basically for non uh, sensitive data, like environment variables. Secrets, they itself like by self they are not secure. They are just encoded in base 64 and not encrypted. Both are different. So secrets are the native Kubernetes object which we can use to store secret. But if we are fetching our secret from somewhere else, it is advised to use external secret providers. Like in my project, I had used AWS Secret Manager and then AWS Secret Manager controllers on EKS to fetch all those secrets and create a native Kubernetes secret that which can be accessed by Kubernetes. We have other tools like Seal Secret, ESOP to make the secret secure, basically.
Yeah. So, for example, if we are using some AWS Secret Manager to
Yes.
save the secrets, how can this be used in Kubernetes? How you will refer those things in Kubernetes?
So the very first thing is we need to have those controllers available on our EKS or any other cluster that we are using. After that, we should have the proper uh, I not proper authorization and access level to fetch those secrets. After that, it varies on the provider, like from where we are, which provider we are using. In case of AWS Secret Manager, we have to create objects, seal secret objects that fetch those secret in our cluster, and then there is another object that creates a native normal Kubernetes secret which can be accessed by other application. So like overall we need the controller and permissions and the object secret
Yeah.
objects.
So actually, we have to create a service account so that Kubernetes will be able to access AWS, and then we have to pass in
Yes,
the
yes,
variables in the configuration file so
yes,
that
yes,
we
yes.
will be able to communicate with that secret. Okay, so it will be more
Yeah.
secured.
Yeah, yeah. I have
S-
used like pod identity association for all this.
Okay, so for example, like you have a pod, it is in crash loop back. Okay, so what are the
Yeah.
steps you will take to troubleshoot that one?
So crash loop backup basically our pod is continuously restarting.
Mm.
So to troubleshoot, we can first check the pod logs. If there is nothing suspicious there, we can check the events of the pod using the Kubernetes kubectl describe and then the pod ID. Uh, After that, we can see if our pod configuration or manifest file has any uh, specific, let's say, resources requirements that are not met by our node, or any taints or affinities that cannot be, let's say, which cannot be facilitated by our scheduler, or our node is
Not
out of
actually, not
memory.
actually. So the first thing is like you shouldn't check logs. Like you can check, but the thing is like describe will give you kind of events like overview of that issue. In when you check the logs, obviously the error will be there. Okay, so
Yes,
you should look for the keywords like error, failed, or something so that you will get
yes,
to know.
sir.
So based on the logs itself, you will be able to find like what exactly the issue is. In case if there is some issue in the configuration YAML files, then obviously like it will be like a error and it will be in the logs. Okay.
Yes, sir.
Yeah. Are you have you used any monitoring tools or something?
I have used Prometheus, Grafana, and Uptime Kuma for my server.
Okay. Like you are aware of CloudWatch as well, right?
Yeah, of course, CloudWatch is also.
So what is the difference between Cloud Trail and the CloudWatch?
Uh, Cloud Trail, like it has all the uh, events basically regarding the. Okay, I guess
Yeah,
I
like
am
whatever
forgetting.
action or you perform on the AWS environment, everything will be logged in
Cloud
trial.
Trail.
Yeah.
Yeah.
So CloudWatch, it's like for monitoring the cloud resources.
Okay, okay.
Okay. Yeah. Mm, yeah, Shubham, that's it. It was like very nice interview actually. So you answered most of the questions. So
Yes, sir.
in my opinion, like you are selected. In case if you are attending an interview, you are selected. Okay. It's very good. Keep it up. And guys, if you're watching till now, like Shubham is a fresher and is just having like 10 months of experience and answering questions to this extent, no matter like which company attends, definitely will be able to crack. Okay, just the questions may be like a bit easy or it's kind of freshers questions. So how Shubham answered, it's very good. Okay, so based on this, we can tell like he is proficient in this DevOps. All the best, Shubham.
Thank you, sir.
Um, yeah,
It was
if you
really nice.
yeah, Shubham, like just prepare in case like if you are more thorough, we can go in depth interview once more. We can
Yes, sir.
connect later once more. Okay. And
Yes, sir.
meanwhile, guys, in case if you want to give mock interview, just drop a mail to my email ID so that I will schedule the interview based on our availability, like based on your and availability and my availability. We can schedule a meeting and then we can connect. Okay. So in case if you like the video, just like, and congratulations, Subham. Like it is nice speaking to you. Yeah,
Likewise, sir.
yeah. Bye. Thank you, guys. Bye.
Yeah. Like, is the